What's happening, people? So today's lesson is compound interest and depreciation. We'll look at how to actually work out compound interest and depreciation. And then I've got a couple challenge questions, a couple tricky things I want to take a look at with you guys. First things first, there's a lot of fancy words that get thrown into this topic, and you might not be familiar with them. So let's take a look at each of these, right? Now, the first one, obviously, the clue is from the title of this video. It's compound interest. What actually is interest? Now, in finance, interest is the fee paid for the use of borrowed money or the return on invested money, typically expressed as a percentage, blah, 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 blah. In basic terms, I take money out, I have to give that exact money back with a little bit on top. A little bit on top, interest. And the same goes for if I'm investing money, anything on top of that can be seen as interest. And it's taken as a percentage. Principal. Now, that's not your headmaster or headmistress at school. Principal is, that was a horrendous joke. Anyway, it's basically the money that you put in at the beginning without any interest added on. So if I invest £1,000, that £1,000 is my principal. That's basically what it is. So money that gets put in without anything added on, your starting value. Now, compound, just in general day-to-day life, it's basically a makeup of several components, parts, elements, whatever you want to call it, right? You could have a compound word, a word made up of several other words. Put those together, compound interest, it's basically interest earned over a certain period of time. So interest on interest. So you get a certain amount of money, your principal, you earn 10%, let's say, on that. Then at the end of that year, you have a certain amount. You then take the interest of your new amount and you keep compounding it year on year on year. That is compound interest. It will make a lot more sense once we look at some examples. So first one, I invest £1,000 at 5% compound interest for 3 years. How much money do I have at the end of 3 years? So a couple things to highlight here. It's an investment, so 9 times out of 10 it's going to be an increase, and it says here 5% compound interest. So underline those words, and it's for 3 years. So let's first work out how much it's going to be for 1 year. So £1,000. Now, if we're increasing something by 5%, if you haven't seen my video on percentage increase and decrease, pause this, go and watch that first, and then come back, and this will make so much more sense. So 5% increase, as you guys know, is 1.05. So multiplied by 1.05. Type that into your calculator, 1.05, and you get 1,050. Now, that's at the end of 1 year. Now, we want to work out 5% for 3 years. What happens now is I no longer am interested in this £1,000 because I don't have £1,000 anymore. I've earned 5% interest on that. So I now have 1,050. So my new calculation is 1,050 multiplied by, again, 1.05. The percentage hasn't changed. So again, multiply your answer by 1.05 and we get £1,102.50. So this is what we call compound interest. Repeat the process, but I'm not going to use 1,050. I'm now going to use my new value. So £1,102.50 multiplied by, again, 1.05. And we get, multiplied by 1.05, 1,157, let's round it, £63. Now, that's your answer. So that's what it is at the end of 3 years. It's quite a simple process. It's repetition. So you do it the first time and it's an increase of 5%. So multiply by 1.05, get your answer. And because you've got like a proper calculator, you can just, when you press equals, you get your answer, just times 1.05 equals, times 1.05 equals for however many years. Let's take a look at a depreciation example. So a value of the car our value of my car decreases by 6%. So straight away, if it's a decrease of 6%, that's now going to be 94%, which is 0.94. Do the same thing again. 23,000 multiplied by 0.94. So 23,000 multiplied by 0.94, 21,620. Now, I've got to do this 3 more times because it's for 4 years. And if I'm being completely honest, I can't be asked because there is such a quicker way to do this. Now, if you have noticed something, a pattern maybe in the first one, well done. Let's take a look at this in a little bit more depth, right? What is actually happening here? Because I'm not going to sit here and do this times 0.94, press equals, times 0.94, press equals. I can, but let me change the question to 24 years time. Yeah, 24. Now who's got the time and effort to go and do that 24 times? I certainly don't. So what we're going to do is we're going to look at the first example, right? And what seems to be happening, or what's the same thing that seems to be happening in each line of working out? Well, as you can see, it's 1.05 times 1.05 times 1.05. So actually, if we were to write this out in one calculation, it would be this, so the 1,000 times 1.05 times 1.05 times 1.05. That should give us this. Now, what is 1.05 times 1.05 times 1.05? Well, it's 1.05 cubed, right? 1.05 cubed, because it's times by itself again. So what do you think is going to happen here if it's for 4 years? So it's going to be 0.94 times 0.94 times 0.94 times 0.94. That's to the power of 4. When you multiply something by itself for a certain number of times, that ends up being the power. Now, can you make a relationship, or can you make a link between the power and the question? Now, I'm hoping you're all screaming at me saying, it's the number of years. Obviously, well done if you said that. If you didn't, no problem. That's why I'm teaching you this. So the power is the number of years, or the time frame that they're given to you in the question. So let's reapproach this question with this new learned information and see how we get on. So we said principal, 1,000, multiplied by our increase, or 1.05. And then we said the power was going to be the number of years, so to the power of 3. So get your Casio calculator. 1,000 multiplied by 1.05 to the power of 3. And wow, look at that. 1,157 pounds 63. We get the same answer in one line of working out. You can do either method. Yeah, you know which one I prefer. Okay, so 23,000 multiplied by it, and it's a 6% decrease. We already discussed this. 0.94 to the power of 4. 23,000 multiplied by 0.94 to the power of 4. Press equals. There you go. Got my answer straight away. 17,957 pounds. And let's round it. 23 pence. So much quicker. And especially if, as I said before, this was 24 years. Like if you have an investment and you want to return on it in 30 years' time, you are not going to do 30 separate calculations. You can do it in one. Okay, let's look at a couple more examples. So this one says you invest £1,500 in a savings account that earns 3.2% compound interest. What will it be worth after 3 years? So as before, we outline key information. So my principal, which is 1,500, it's an increase on interest of 3.2%. So that's 103.2%, which is going to be 1.032. And then we look at the number of years, which in this case it's 3. So to the power of 3, type that in. So power of 3, you get £1,648.66. pence. Easy. Good couple marks there. Again, bicycle example. £400 is your principal. So that's the first thing you will write. Then it says it decreases by 7.5% per year. So again, if you haven't seen that multiplier video, the percentage increase and decrease, go and get really good at that. And then this will seem like a piece of cake. So 100 minus 7.5 is going to be 92.5. So my multiplier is 0.925 to the power of 3. Again, 3 years. No pattern there, just so happens to be 3 again. £316 and 58 pence. So £316 58. It's that simple. I can't make it any more easier than that. Right, moving swiftly on. Let's get you lot thinking. You invest £2,000 in a bank account that earns 4% interest. Okay, nothing new there. Every 3 months. That's not something we've seen yet. What will your investment be worth after 5 years? So without jumping into it and saying, right, it's 2,000 times by 1.04 to the power of 5, that would be if you were earning 4% interest annually and you were doing it for 5 years. But what it says here is you're earning 4% interest every 3 months for 5 years. So let's forget the 5 years for a second. Let's look at 1 year. How many 3-month intervals are there, or how many 3 months can fit into a year, right? It's going to be 4. So 3, 6, 9, 12, right? So if that's the case, if there's 4 lots of 3 months in 1 year, in 5 years, so multiplied by 5, that's basically going to be 20. So at 20 different points, you will receive the 4% interest. So the power is not going to be 5 for 5 years. It's going to be 20 because this specific example, the interest is earned every 3 months. It's not earned annually. Very important that you read the question. So all that happens is your principal stays the same. Your multiplier stays the same, 1.04. Your power then becomes 20 because technically you are getting 20 points at which you are receiving the interest. So type that in and you know the rest. So you get your answer. So 2,000 times by 1.04 to the power of 20, 4,382 pounds 25 pence. There you go. You just have to make sure you read the question carefully. Okay, now it's your turn. Go ahead and pause the video, have a go at these 5 questions, and then I'll put the answers up on the next slide. Here's your answers. Go ahead and mark your work. Let me know in the comments how you got on. If there's any further questions that you guys have, I'll try and get back to you. Now I've got a challenge. So take a look at this. You invest £1,500 in an account that earns 4% compound interest per year. How many years will it take for your investment to exceed £2,400? Now, upon reading this question, the first sentence seems just very almost identical to the questions we've tackled already, right? 1,500 is your principal, 4% compound interest, that's fine, and it's per year, no surprises there. But the question now isn't asking for an amount of money. It's asking for how many years it will take for it to exceed a certain amount. Now, it is pretty much, well, it is trial and error, but it's a little bit more than that. You're going to use some educated estimations, and we'll see how we get on. So if we start with 1,500 and we increase it by 1.04 for 1 year, right? So put that into your calculator, see what you get. You get 1,560. So that's still quite a way away. It's still quite far away from 2,400. So I'm going to change this, and instead of doing it for 1 year, I'm going to say, let's try 10 years, see what happens. So if I now change my calculation and do it to the power of 10, I get hold on. Yeah, 2,220 pounds 37. Now, that's way closer than 1 year. So 10 years is closer. Now, we're only about, what, 180-ish pounds away. So I'm going to increase this again, and I'm going to do for 11 years. So 1.04 to the power of 11, right, even closer. So 1,500 times 1.04 to the power of 11 gives me 2,309. Now remember, I am looking for the first year that it exceeds, it goes beyond 2,400. We are very close, but we are not beyond 2,400. Now let's try it for 12 years and see what happens. You guys are probably beating me to it, but bear with me. So times 1.04 to the power of 12, and there you go, 2,401 pounds 55. So my answer, I can say, is going to be, how many years will it take for your investment to exceed 2,400? 12 years. Simple as that. Okay guys, hope you learned something from that video. Like, comment, subscribe, do all that stuff that you guys do, and I will see you next lesson.